Hi everyone, so this will be the video for the Chapter 10 problem set, and as with the last several, there will be two videos, one for the open-ended questions and one for the multiple choice. If you have any questions, please reach out, let me know, and I will gladly answer questions, set up office hours, however I can help. So for our open-ended questions, when you look at the PDF that is posted in Canvas or Blackboard, there will be two sections or two pages for each of the slides in the open-ended section. One will be using calculus and one will be using the formulas that are given to you in the notes. It doesn't really matter which one you use. I just kind of wanted to show you that the formulas are not just from the middle of nowhere, I guess. They actually are coming from something else. The video, for the sake of time, will only include the formulas rather than the calc, but both are on the PDF, and it's in hot pink, so it's really easy to tell which one, but just so you're aware. So the first question says, the following cubic equation is a long-run production function for a firm. Suppose the firm employs 5 units of capital. 5 units of capital is telling us that K equals 5. What are the equations for the total product, average product, and marginal product of labor curves? So our total product is going to be Q equals and we are just going to substitute 5 in everywhere we see the K. So negative 0.0035 to the third, L to the third, plus 7.2, 5 squared, L squared. And when you multiply that all the way out, you're able to get negative 0.375 L to the third plus 180 L squared. So with that, we see that our A is equal to negative 0.375, and our B is 180. So our average product curve is quantity divided by labor, which is going to give us negative 0.375 L squared plus 180 L. And then our marginal product is going to give us negative 1.125 L squared plus 360 L. And the way you find your marginal product curve is you're either doing the partial derivative with respect to L, or you're plugging into the formula 3a L squared plus 2b L. It doesn't really matter which one, as long as you know what you're doing. Either way will get you the exact same answer. At what level of labor usage does the marginal product of labor begin to diminish? So we're looking for the maximum. So that's going to be L equals negative B over 3A, which is a negative 180 divided by negative 1.125, which is going to give us 160 units of labor. Calculate the marginal product and average product when 12 units of labor are being employed. So this 12 units of labor means that L is equal to 12. And we need to substitute in. So our average product is going to be negative 0.375 times 12 squared plus 180 times 12, which gives us 2,106. And then our marginal product at 12 is going to be negative 1.125 times 12 squared plus 360 times 12, which is 4,158. Now suppose the firm doubles capital usage to 10 units. So this means instead of our K equaling 5, our K is going to be equal to 10. What are the equations for total product, average product, and marginal product of labor curves? So just like before, our total product is just substituting in that 10 for our K in our original formula. So Q equals negative 0.003, 10 to the third, L to the third, plus 7.2, 10 squared, L squared, which is going to give us Q equals negative 3 L to the third plus 720 L squared, which means we have an A equal to negative 3 and a B equal to 720. Our average product is going to be Q divided by L. So that means we're going to have negative 3 L squared plus 720 L. And then our marginal product is going to be negative 9L squared plus 1440 L. And again, you're either using this partial derivative formula, taking the derivative of your total product with respect to labor, or you can substitute it in. Doesn't really matter, just know which one you're doing. So what happened to the marginal and average product of labor curves when capital usage increased from 5 to 10? Calculate the marginal and average product of labors for 12 units of labor. So our average product at 12, we're going to substitute 12 for our L, just like we did on part C. Is going to be negative 3 times 12 squared plus 720 times 12, which is 8,208. Our marginal product of 12 is negative 9 times 12 squared plus 1440 times 12, which is 15,984. So did the increase in capital usage affect marginal and average product? Yes. It affected both by increasing AP and MP when labor is 12. So the next question. Again, there will be 2 slides on the original PDF that's uploaded so that you can see the calculus version if you're into math and you want to see it worked out with the derivatives and such. That's what the calc was for. Second one gives us a regression output. And first, we need to set it up where we have our quantity equals, and then we're just going to substitute in. So the parameter estimate in front of our L cubed is going to be negative 0.00160 L to the third plus 0.480 L squared, which means we have an A value of negative 0.0016 and a B value of 0.480. So our total product is just this. It's just writing down what we already have, what we're able to pull from the regression equation itself. Our average product is dividing our total product divided by L. So our coefficients stay the same, and our exponents decrease by 1. Which again, that's either using division or it's using your formula rules. And then our marginal product is going to be negative 0.0048 L squared plus 0.960. Are they parameters of the correct sign, and are they statistically significant at the 1% level? Yes. Correct sign. A should be negative and B should be positive, but not statistically significant at the 1% level. And we know that because of our p-values in that final column. At what level of labor is average product at its maximum? We're going to use negative b over 2a, which is going to be negative 0.480 divided by 2 times negative 0.0016, which gives us 150 units of labor. And then it gives us some formulas that were derived in Chapter 8. Assume that the wage rate for labor is $50. What is output when average product is at its maximum? We already said the average product is at its maximum at 150 units of labor, so substitute in 150. So that means we're going to have Q equals 0.0016 times 150 to the third plus 0.480 times 150 squared equals 5,400. I apologize if y'all can hear that. I have a dog who is just over a year old and her name is Evie, and we are barking at cats that are outside. At the output level for Part D, what are average variable cost and marginal cost? So first we need our average product. So Q divided by L is going to be 5,400 divided by 150 equals 36. And the reason we need this is because marginal product equals average product at maximum of the AP curve. Which means that our marginal product is also equal to 36. So our average variable cost is going to be wage divided by average product, which is 50 divided by 36, or $1.39. And our short run marginal cost is going to be wage divided by marginal product, which is the same thing, 50 divided by 36, which is $1.39. When the labor usage is 75 units, what is output? What are average variable cost and short run marginal cost at that output? So when labor is 75, we're going to substitute that in, and we're going to get negative 0.001675 to the third plus 0.4875 squared is 2,025. So for our average product, that's Q divided by L. So we're going to have 2,025 divided by 75, which gives us 27. For our marginal product, since we're not at our max, we actually have to solve it. So marginal product, we're going to substitute in to this equation right here at the top. And for the sake of space, I am just going to tell you that you get 45, because otherwise I will not have room to write the rest of anything. So our average variable cost is wage over average product. So that's going to be 50 over 27, which is $1.85. Your short run marginal cost is going to be wage over your marginal product, which is going to be 50 over 45, which gives us 1.11. How can the entire set of relevant cost curves be derived for this estimate of the production function? You would repeat E and F for all levels of output. And the only way that that would be reasonable is if you were using a computer and it could do it for you. Otherwise, it would take forever to plug it all in by hand. Use Excel, use Stata, use whatever your preferred software is. So the last short-ended question, open-ended question, whatever we want to call it, says consider estimation. We have the same thing set up. So we're going to have average variable cost equals 45, because that's our intercept, minus 0.075 Q, because that's our B, plus 0.000096 Q squared, because that's our C in front of our Q to the second. Do the parameter estimates have the correct sign? Are they statistically significant at the 5% level of significance? Yes and yes. We expect B to be negative and we expect C to be positive. C being positive makes our function look something like this. So C has to be positive, otherwise it's a upside down, it's a hill instead of a smiley face. And they're statistically significant because our p-values are less than 0.05. At what level of output do you estimate average variable costs reach its minimum value? We find this with negative b over 2c, which is negative 0.75, well, sorry about that, 0.75 over 2 times 0.000096. And a negative times a negative for our b value makes that a positive. So that gives us 390.625. What is the estimated marginal cost curve? So we're using our formula and we're just substituting in. So that means we're going to have 45 minus 0.15Q plus 0.000288Q squared. What is the estimated marginal cost when output is 1,000 units? So we're going to plug that into the formula we just found. So it's going to be 45 minus 0.15 times 1,000 plus 0.000288 times 1,000 squared. And that's going to give us $183. What's the estimated average variable cost curve? Again, we're just using the formulas. So we're going to have average variable cost equals 45 minus 0.7075 Q plus 0.0096 Q squared. Actually, we're using the formulas, but it's already up here. We had to figure that out to even do it, so I'm not sure why it's at part E, but that's all right. And what is the average variable cost when output is 1,000 units? So substitute in 1,000. So we're going to have average variable cost of 1,000 equals 45 minus 0.075 times 1,000 plus 0.000096 times 1,000 squared, and that's going to give us 66. These are the formulas that we're using when we're starting off with a short-run cubic production function, which we know is when we're starting off with a Q. These are the formulas that we're using when we're starting off with a total variable cost curve, which starts off with total variable cost and has Q in the equation instead. They are on the PDF that is uploaded, just so that you don't have to go back and forth and back and forth. As always, the next video will have the multiple choice questions, and if you have questions on any of them, please reach out and let me know, and I'll gladly help. Have a good week.